Hello everyone. So today I would like to do a bit of a series, or well, it's mainly just going to be me coding, but what I'm going to be doing is making some basic applications in Python probably at first, just to well, do some trading on IMX. So basically making some trading applications for use with IMX, but instead of them being web applications, which is what the official SDKs or the official APIs and everything that Immutable X itself has released support, do some more desktop programming, so Python, C#, C++. So I've already made a library for this in the past few weeks, so that's this one. So this is just a C++ library for trading on IMX. So what I would like to do today is just see if I can implement some of this in Python. So I can just use this this library itself and just port some of the methods over so that I can call them in Python. I'm not really used to live streaming, so it's probably just mostly going to be me programming. So, but I'll try to explain at least some of what I'm doing. So yeah. Now, if you actually want to use this, there's a few things you can do. If I'm just going to be using the DLLs in Python, I can just use the IMXlib zip file, but maybe it's nice to actually look at the Visual Studio project first. So let me just extract that, and then I'll show you. I'll show you the basic setup first. Yeah, you should be able to see my screen now. So basically this sets up everything for you. So there's a few dependencies you need. Curl is just used for just sending data back and forth with for doing HTTP requests. I mean, that's what curl is for. So with the IMX, with IMX itself, and then of course there's the IMX library here with some header files and the actual libraries. So if I open this, it should just load immediately and should compile fine. Yeah, so this is the basic setup that you'll get at first. So not really anything special. It creates a generates an Ethereum private key, gets the address associated with it, and then signs a message. So if I run this, let's set this to Win32, but x64 should work fine as well. Let's just see if it builds first. Yep. Okay, so we got a private key, an Ethereum address, and the signature for a message. Looks totally fine. Now, of course, this isn't really doing anything with IMX. It's just generating a private key, an address, and signing a message. So nothing interacting with IMX thus far. But of course, we have access to methods that we can use for that. So for example, just as an example, I can register an address with IMX. So let's just try that. Once this actually loads. Yeah, so there's a few functions here for interacting with IMX, but let's do something simple, just registering address first. So we just pass the key, and so the result buffer and buffer size, these are just for returning the result from the server. So we need to reserve some space for that. So let's do that. So let's just give it like 1,000 characters for storing the result. That's more than enough. We're not going to need that much, but It's better to reserve more space than you need than too little, of course. Oh, and let's make sure we print the result also. I mean, the result of this isn't really super interesting to print, but... Okay, so now if we load this again. Yeah, so this address is currently not registered with IMX. So we can actually test that. Let me just hang on. I'll just show you the desktop in its entirety. It's probably easier here. So let's say I import this key into MetaMask. Oh, hang on. Just wait a second while I log into my account or log into MetaMask. I mean, there's not much in here, but still. Okay. So let's add an account. Oh. Import. And right away we should be able to see that the addresses match. So 66E5, 66E, 7289, 7289. So yeah, it's exactly the same. And as I said, currently it's not registered. So if we go to the Immutable X marketplace and we try to log in, we should get a message saying that we need to set up an Immutable X key in order to use that wallet. So let's see if we get that message. Yeah, so we get a message that says set up Immutable X key, and if we click setup, we should be asked. It should ask us to sign another message, which I will cancel. And we can't really do anything with the wallet on IMX until we sign that, of course. But we can also do it in here. So if I hit enter here, we get a response from the server, and now we should no longer be getting that message. If we try to connect it this time. Yep. And this time it just worked immediately. Now, of course, if you want to use C++ for this stuff, just check out the README or look through the actual functions in the header or CVP file. It's probably easiest to just look here. And you can check how they're implemented also here. But that's not really what I wanted to work on here now. So let's try to build something in Python. Let's see, how can I best show this? So let me just quickly set up a new project. Don't think you can actually see this. Oh wait, actually you can. Python application. Let's just build a basic marketplace for Gods Unchained. So let's just call it PyGU Market. Yeah, looks fine. Okay. Yeah, so we're going to need to link to the DLL file for the C++ project that we just looked at. Now there's a few ways that we can do this. Of course, we can just take the files directly from the project that we built just now, which is like in here. If you go to, hang on. So in the releases tab, there's an IMXlib.dll file. That would work, and you also need the libcurl DLL. But I mean, these are exactly the same as the ones you can also get from the releases tab. So the ones that's I'm probably just going to use is from here. So all I'm just going to do is extract these here. And these contain DLL files for 32 and 64-bit for IMXlib as well as libcurl, and the actual elliptic curve used for signing transactions on IMX. So you need all of those. So let's go back to Visual Studio. So of course, since we're working with native DLLs, we'll need to use C types for this. So we'll import C types, and first thing we'll probably need is CDLL. Oh, hang on. Actually, I'm probably just going to make a separate module as a wrapper around the DLL, so we can call functions from that. So I'm not going to use C types in here. Let's just create a new module. Call it IMXlib or something. There we go. We can close this one for now. And we'll make this the startup file. Okay, let's start with the basics. So if name... God damn it, I can't type today. Let's just print hello world. Good place to start. There we go. Okay. C types, CDLL. Okay, so first I think we should probably construct a path to the actual DLL file. And so we can actually first test whether or not we're running 64 or 32-bit Python, because depending on which one we're running, we need to load a different DLL, either 32 or 64-bit versions. So we can check that by importing platform. And for now, I'll just print architecture. I think this is right. Oh. Platform. Yeah. So as you can see, it says 64-bit. Because I'm running 64-bit Python. Let's call it Arch. Actually, no, let's do Arch equals. Let's make the default Windows 32. And then if 64 in X64. Okay. Let's get the actual path. We need OS. OS.path. path. Hoping I'm typing this correctly. Let's first check what we get. Seems about right. Or should it be path sep? I think so. No. It's path.sep. Yeah. And then let's make a separate variable for DLL name. Yeah. Okay, that looks to be correct. Take that out. And then we can load the DLL itself. So IMXlib is cDLL. And that should work. It should not give us any errors. No, it doesn't. Okay, great. So let's see if we can implement some of the methods that we looked at before. So generate key. That doesn't take any arguments. And now we're working in Python, so of course we're just going to return the actual string, or no, actually we can return it as an integer, so just the private key as an actual number. But we're not gonna work with strings where we have to pass a buffer to the method in Python. Of course, that's more of a C++ or a C++ thing. But of course, when we do need to create the buffer itself if we're going to be calling a method in our library. So I think it's create string buffer. Yeah. So we'll create a buffer for that. Ethereum keys are 32 bytes long, so the amount of characters I need is going to be 2 characters per byte, so 64, plus the 0x prefix is 36, plus 1 more to terminate the string, so the null terminator character. So we need 37 characters. ETH generate key res and 37 characters. Let's just print. I think I need to do value.code. For now, we'll just try it like this. Yeah, so that should give us a different... Hang on, isn't that way too short? Hang on. Oh, I'm stupid. 32 characters. That's 64 plus that's 67, not 67, not 37. Just about to say that's much too short. Okay. Now it should be fine, right? So if I just, let's make sure. Oh. Just to make sure that it's the correct length. Yeah, 66 characters. That's correct. We'll return this as an integer. Oh. Get a giant number. Seems about right. Let's convert this back into a hexadecimal number. Yeah. Looks to be right. Okay. Let's see if we can get the address for the keys we generate. Get address, I think, was the function. Check real quick. Yeah. And this, of course, takes the private key as an argument. So private or Ethereum addresses are 20 bytes long, so that's 40 bytes plus 3, so 43 characters. Let's hope I get it right in one go this time. Now, of course, this could be an integer or it could be a string, so let's check if it's an integer first. Is instance. Key int. In that case, we'll just turn it into a hex string again. So we'll say private key is string x. Actually, let's call it eth key. That makes more sense, probably. Res 43. Oh, and this is not gonna work. We need to encode this into a byte string. Because it's not gonna know what to do with the Python string, so we need to encode it into a byte string, which then can be passed as a C string to the actual library. And then we'll return res.value.code. We'll turn this into an integer also. Key. And address is going to be key. Let's do some F strings. It's hexadecimal again. Do the same thing here. Key. Okay. Let's see if we can sign messages. Oh. That's going to be a string. Okay, so this time the result buffer should be string buffer. Oh, why is this not working? Okay, whatever. So Ethereum signatures are 65 bytes long. 1 byte longer than you might expect, because there's the recovery ID, which is in the last byte, which is always 1B or 1C, so 27 or 28, I think. Yeah, 27 I think is 1B and 28 is 1C. So 65 times 2 is 130, plus 3 again, 133 characters. You can actually copy paste this part. We'll do IMXlib, sign message. And first one should be the message itself. So message.encode UTF-8, followed by the Ethereum key. And we'll do the same thing again. I think that should work. So let's let's create a message here. Let's do hello world. And let's print that. Yeah, as you can see, it ends with 1C. So like I said, all signatures should end with 1B or 1C. Or well, I think there's like a very, very, very small chance that it's something else, but I'm not exactly sure anymore how exactly it works. I mean, I looked it up once, but not really sure anymore. Okay, actually, maybe we should check whether or not these are correct. Whether or not the signatures work. Oh well. Let's just check. Let me set this up. Just quickly going to import this key again into MetaMask. I'll delete the other one. I'll share my screen in a second once I have this set up. Okay. All right, so in my Ether wallet you can sign custom messages as well, so that's the easiest way to test this. So just access my wallet. The 0x50F7372. sign message, and we did hello world with an exclamation mark. And well, that looks like it's exactly the same. So 0x3533 something 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 1c. So like I said, when that this always ends with like 1c or 1b, it can also end with 00 or 01, but these are the exact same as 1c or 1b. So if I actually copy this, might be nice to just show. So this will verify. Now of course, if you change the signature at all, it should no longer it should fail to verify. However, if I change 1c to 01, it will still verify, because it takes the modulus of this number with 27 and then uses that in the verification. And just so, even if I change this, it still works. That's pretty interesting. Let's go back to Visual Studio. Actually, you know what? Let's see if we can register the address I just added. So let me just get the private key again. I imported it in MetaMask, so I'm just going to export it now. Because I already closed the window, and if I launch this again, it's just going to generate a new key. Right. So now we'll always get the exact same numbers every time we open it. That works. Okay, let's see if we can register that as a wallet on IMX. I mean, of course it doesn't matter, but I'm trying to stick to the same names I used previously. Oh, address. And it takes an Ethereum key. Now here, I usually just reserve 1,000 characters, just because that's definitely enough. And I don't really know what the server's going to return. So just to make sure that I have enough space. It never creates a buffer overflow, even if the message returned is longer than this, then it will just cut off. It will stop writing past the or the function in C++ will not write past the buffer as long as you enter the correct buffer length. But it will cut off the final characters if there's more data than the buffer can hold. IMX register address. ETH key result and 1,000. Dot value dot code. Right. So this time it's not going to be a number, so we just decode the string into a normal Python string and then return that. We'll do input again. Actually, let's just register it immediately. Doesn't really matter. missing. Valid ETH signature. What the hell? Did I do something wrong? Huh. Let me check what's going on here. Interpret as integer. Oh. Yeah, of course. What did I do wrong? Invalid ETH signature. What is happening here? Oh, I'm stupid. I already know. I didn't encode the message. Ah, that's stupid. But hey, at least we got to see an error message from the server as well. So it did pass. I don't know exactly how it handles this if I don't encode it, but something went wrong. So yeah, so I do need to encode this in order to pass it along. So that's what I forgot. So it should work now. Now I should... Oh, hang on, let me go back to where this still was. There we go. Yeah, so this time it did work. Now we get the TX hash, so now it did register. Okay, but good to know. Yeah, so you do actually need to encode it into a byte string in order for it to work, otherwise it doesn't pass it along correctly. And weird things happen. Okay, what I think I'm going to do, because I would like to at least show a sale being created using the library, so that's probably the last thing I'll do today, and then I'll continue this later. Now, of course, in order to do that, I'll need to just set up a wallet and transfer like a very cheap like God's Unchained card or something else into it so that we can create a sale for that. So I'm going to change scene to the waiting room again, and then just set up an account, and then we'll create a sell order for that. So be right back. Okay, and I'm back. So what I did was I created a new file called keys. I put a key in there, so that way you won't be able to see it. So yeah, so now it just shows the address and the signature. I removed the line that prints the actual private key itself. I mean, it's not like there's anything special in this wallet. I mean, it's entirely empty except for a 1 cent God's Unchained card. So nothing really to steal there, but still. Just probably still better to do it like this. Yeah, so if I go to the actual wallet on Immutable X, I'll show it to you in a second. Just need to log in. So this is the wallet, has one card in it, an aspect juggler, which of course isn't really worth anything. But like usual, we can create sell offers for it on here, on Immutable X. And we can also see the card. I transferred this yesterday. So this is a wallet I set up yesterday for this. You can see the asset itself here. So let's see if we can create a sell order for this card on IMX using the library. Let's switch back to Visual Studio. Okay, so there's a few things we need for this. Hang on, let me actually I'll show you the function definition in the library itself. So the self function takes a few arguments. So it takes an NFT address, ID, token ID, price, fees, the number of fees to add, and then the private key and result buffer. So what are all these and where do you find them normally? Well, I think I'm going to show where you find these numbers, where you find these values later, or how you can find them through the API later. For now, we're just going to find them on Immutable itself. So the address is always going to be the same for every asset within a collection. So all Unchained cards are going to be located at this address, and then they just have a different ID number, which is displayed there. Other numbers that we need. So an ID string, token ID. So that's just the currency that we're going to be selling it for. So we're just going to be using ETH. You can use these numbers in here, and you can see what these values are hard-coded. You can check what they are also if you just check the actual code. So they're here on the top. For Ethereum, it's just ETH. For everything else, it's the address of the token. But you can use all of these. That's fine. For now, we'll just use ETH. Let me quickly copy the function definition before I return to Visual Studio. Okay. So, address, ID, token ID, price is going to be, or no, hang on. Well, I could make it a float, but doesn't really matter. Fees. So here we're passing the number of fees and a pointer to the first fee to our function, to our library, but of course in Python we can just pass an array here, and we don't really need to keep track of the length of this array ourselves. Okay. So we can do copy paste that part again. Now in this case we can actually do the same thing for the address, ID, and ID, not for the token ID. Or no, actually we can. We can just check if it's because we check if it's an int anyway. So even if it is a string, it will just stay a string. And lastly, for the token ID, okay, so now the fees are going to become a thing, because the library is expecting a struct within it 43 character address and then an integer. So we'll have to recreate that here. So we'll import structure, char and cint, make a class called fee structure of field which takes two fields. One is going to be the address, which consists of 43 characters, and the other is going to be the fee percentage, which is just going to be an integer. Yeah, that should work. Oh, hang on. That's not going to work. So let's pass along our functions. So NFT address. Let's make sure to encode things this time. We know what happens if we don't this time, so token ID the price. Oh, that should be a C double. Did we import that? No. It's expecting a double. So let's make sure it is. Okay, and now we're going to pass the fees, and we're going to pass these as a pointer to the first element. So we'll have to create a fee pointer for this. So that's going to be fee times len fees, and then just that's how it's supposed to work. And then just len fees, so that it also knows how many fees we actually passed. Okay. Well, I mean, this is totally unreadable. Let's make it like this. Okay, let's see if this is correct. So address, ID, token ID, price, fees, and private key. Create a buffer of 1,000 characters to store the results. Convert these numbers, or if they are numbers, we convert them to strings. So ethereum key, NFT address, ID, and token ID. And then we call this with the address that matches ID, token ID, price, fees, length of the fees, private key, and the result buffer. And then we decode the result. Yeah, that should be fine. Let's delete that line. Let's remove the lining stuff. Still print the address, that's fine. Okay, so let's get all our variables. So like I said, the address is this number and the ID is that. So let me just copy paste those. All right. Well, what should we make the price? Let's do something like 1 ETH or something. I mean, we're not going to actually sell it. We're just going to try and create a sell order. No one's gonna buy that for 1 ETH, of course. And let's add a fee as well, so we can see how that works. So we'll do fee is fee. Let's see. And we'll add our own address. Hang on, what was my address again? Now, of course, since this is a C char, so this needs to be a byte string. Let's do this. And let's add like a 10% fee, or let's do something ridiculous. Let's do 50%, just to make it very obvious that an extra fee is being added. And then we'll call with our address the token. Well, let's just do ETH. I mean, like I said, you can get these from the library as well. I'll show that probably next time. But for now, let's just do ETH, just to make it easy. Price, fees. Oh, yeah. So that should be an array of fees, and then the key. Just go here so I can actually show the screen so we can see if it works. All right, so as you can see right now, it's not on sale. We run this. Oh, reference for assignment. What did I do? Let's see. Oh, because I called it ETH brief here. Well, it's called a ETH key everywhere else. Does it work now? Yeah. So if I go back, now it's on sale for 159 for, yeah, so it's 2% protocol fee, 5% royalties, 1% maker marketplace, 50% which we just added, and another 1% taker marketplace fee. Now, of course, normally you wouldn't add fees this high. It's kind of ridiculous, of course, but just to show that it actually does work. We can change this, of course. Let's make it like 25%, just to show it should change. Come on. Yeah. So now it's 27%. All right, so we've set up some, well, we created a sale on IMX, so that's, I think I've been online for an hour right now. So I think I'm going to end this here. So we'll do buying, transferring next, and then we'll make it like an actual program such that we can actually use this, because of course, if you have to look up the ID for every NFT or for every card or anything you would like to trade, that doesn't really work very well. So we'll take a look at how the actual IMX API works and how we can use that to find the data we need and create trades that way. So yeah, I'll be back later.